Okay, so we don't have a way to directly evaluate this yet, but what we're going to try to do is rewrite this inside fraction. So we have 1 over x minus 2 times x minus 5. I'm going to suggest that actually we could write this as the addition of two fractions with different denominators. So kind of like a throwback to that warm-up. With some sort of numerator. Right? This would be their common denominator, right? So I'm suggesting that actually we could rewrite it and separate it out into two what we call partial fractions. So this is a new technique of integration. Oh, minus 5, thank you. I can't read my own handwriting. Thank you. So does that make sense that I could have added two fractions to get this, possibly, with that denominator? Now, if we were doing this, so our job is to actually find what that a and b could be to make this addition work. And so what we're going to do is actually combine these fractions. So in order to combine the fraction, I have to find a common denominator. We already know what it is, right? X minus 2 times x minus 5. So what do we need to multiply the first fraction by? So we've got in the numerator a times x minus 5. And in the denominator, we have that common denominator that we're looking for, plus. What do we want to multiply the second fraction by? So b times x minus 2. Remember, whatever we multiply in the numerator, we also need to multiply in the denominator. Now do we have the same denominators?
Yes.
Okay, we're going to combine the numerators, and I want you to go ahead and let's actually multiply out the numerators. So distribute that multiplication. And all of this has to equal 1 over x minus 2. So in the numerator, we would have, for the first fraction, ax minus 5a plus
Bx minus 2b.
Now combine the like terms. Right, our job is again trying to solve for a and b, and we know what should the numerator equal. 1. We want it to equal 1, okay? So in the numerator, we've got a and b, both in terms of x, so I'm going to factor that out. So the ones that are multiplied by x are a plus b. And then we have minus 5a minus 2b. And all of that equals 1 over that fraction. Okay, now here's the step where we have to actually figure out what a and b need to be. So notice in the original fraction we've got 1 in the numerator. How many x's do you see? None. So this is really 0x plus 1. It's just not there, right? I haven't written that. Which means if I have no x's here, what does a plus b have to be? 0. So I'm going to set that equation. So a plus b has to equal 0 because I have no x's. Can you write another equation about a's and b's?
Negative 5a minus 2b is 1.
These are the constants, and negative 5a minus 2b has to equal 1. So negative 5a minus 2b has to equal 1. Now we just need to solve for a and b. So you can use substitution, you can use elimination, any method so that you can actually find what are the values for a and b. So it might be helpful to solve one of these in terms of the other. We can solve this out. A has to equal negative b. And then I'm going to input that into the other equation. So I'm substituting in A in terms of B. So now I have an equation all in terms of B. We get 5b minus 2b equals 1. So 3b equals 1, and that means b has to equal 1/3. What is A then? Negative 1/3. Now we're going to rewrite the very original integral, because now what we've done is we've decomposed it into partial fractions, is what we've called, is what these are called. And we're going to rewrite the very original integral. So we had the integral of 1 over x minus 2 times x minus 5 dx. But we just rewrote this entire fraction. I can't scroll up, so can you remind me which one is about A? Which one has A in the numerator? What's the denominator? Okay, thanks. Forgot. And the B one is 1/3, and its denominator was x minus 5 dx. Now can we integrate it when we've written it like these fractions? Because we just have a constant in the numerator, and then you just have x minus 2 in the denominator. So it sounds like a natural log function, probably, for the antiderivative. So take the antiderivative to see how we can break this one down.
Wouldn't it just go to the top?
When would go to the top?
You have 1/3 divided by something else, so wouldn't you just get like negative x minus 2 over 3?
No, because when you divide fraction by fraction, the denominator goes into
Oh, you would be multiplying by its reciprocal, though. So it'd still stay in the denominator.
So you get negative 1 over 3 times x minus 2.
So this is really negative 1/3 times 1 over x minus 2 as the constant. And you guys already showed in the warm-up, the antiderivative of 1 over x minus 2 is just what's the antiderivative of 1 over x minus 2? Michael.
The natural log of the absolute value of x minus 2 plus c.
Plus c, and we just have that constant that's just hanging out, so the constant just stays there. So negative 1/3 times natural log of x minus 2, and same for the next one. So the constant here is 1/3 natural log of x minus 5 plus c. So when I have that fraction that I couldn't otherwise directly find, what we're going to try to do is break it up into fractions. That's sort of what the method is using this. And then you're going to rewrite the integrand with that. Any questions so far? I know this was like a long process, but questions on any piece of it? You okay? All right. So let's take a pause on this. How do I end this? How do I stop recording?